try and solve this integral. If you can do it, good for you. If you can't, then you're in the right place. And I'm going to go through the solution now. So the first thing we notice from looking at this integral is that it's an improper integral. So let's first make it a definite integral that is possible to work with. So we do the limit as t approaches infinity and the limit as s approaches negative infinity of the integral from s to t. And then we'll try and think of a possible way that we can solve this integral as if it was an indefinite integral first, because that's essentially what's required when we're solving definite integrals. So we're thinking of a way we can solve this. And now what you notice is that x to the power of 6 is simply x cubed to the power of 2. And that's very interesting because the derivative of x cubed is 3x squared, and we have an x squared in the numerator. So that seems like a good place to go. So we'll start off and we'll substitute in, or let's rather take out this 9, because that may be a problem for us. So let's go ahead and say the limit as t approaches infinity and the limit as s approaches negative infinity from s to t, and we take out that 9. So basically what we're doing is 9 into 1 plus x to the power of 6 over 9. That's the denominator here. And now we're going to want an x cubed to be squared. So the root of this whole term here is simply x cubed over 3. So that's how we can write that. And we can put that in there. There you go. And that's going to be our new denominator, this right here. So let's go and put it in there. X squared dx. Then what we say is, let u equal to x cubed over 3. So therefore, the derivative of u in terms of x is going to be x squared dx. And that works out perfectly, because we see we're going to be substituting in for x squared dx du. So let's go ahead and continue. The limit as t approaches infinity, and the limit as s approaches negative infinity from the integral from s to t. And then we can take out this 1 over 9 here. You can see. We can take that out the integral because it's a constant. And then we substitute in for u. We substitute in u for x cubed over 3. So we have 1 plus u squared dx. Because then we also substituted in du for x squared dx. So now we'll carry on with this integral. And we notice that this is simply, the integral of this is arctan of u. So we say the limit as t approaches infinity and the limit as s approaches negative infinity of 1 over 9 integral of s to t, or rather, we just write it now immediately, arctan of u from s to t. Now I can substitute in t and s straight away because we're going to be using these limits as t approaches infinity and as s approaches negative infinity. So usually what we do at this stage in integration, when we're substituting in a new variable, we got to change the limits of integration, which is this s and t. But you'll notice here that if we're integrating in terms of x from s to t, as is done here, then for u, if we substitute in s into here, then we get s cubed over 3. And the limit as s approaches negative infinity of s cubed over 3 is still going to be negative infinity. So that remains as s, and that's going to remain as t. So it's okay for us to leave these limits of integration as they are. So we can sub them straight back in for the u over here. So let's go ahead and do that, like we would for a normal definite integral. And we say the limit as t approaches infinity and the limit as s approaches negative infinity of 1 over 9. Then we have arctan t minus arctan of s. And then we'll carry on. And we know that the limit as t approaches infinity of arctan of t is going to be pi over 2. Because if you think about it, as x approaches pi over 2 in the graph of tan of x, your y approaches infinity, because tan of x looks like that, has an asymptote at pi by 2. So as your x approaches pi by 2, your y approaches infinity. And since arctan is the inverse of the tan function, our arctan looks like this. So as our x approaches infinity in our tan function, our y approaches pi by 2. Let's get rid of this so we can carry on. I hope that's intuitive. So we say 1 over 9 into pi by 2 minus, and now arctan of s, remember, I drew it like this because tan looks like that. So the inverse of this is going to be that. So as arctan of s approaches negative infinity, or as s approaches negative infinity, arctan of s approaches pi by 2. Negative pi by 2, sorry. So you substitute in here, negative pi by 2. So now we have 1 over 9 into pi by 2 plus pi by 2, which is just equal to 1 over 9 times by pi over 9. And that's the integral solved. So that's it for day 98. I hope that you managed to do this by yourself beforehand and got it all right. And I'll see you tomorrow for day 97.